Okay, here we are doing activity 8 on October 6th, Tuesday. I'm going to make this short because I wanted to get this out about an hour ago, and I want you to give you plenty of time to work on this. So we're looking at compositions of functions and domains. Now I know you're working on this in class, so we're just going to do a whole bunch of problems. I'll run through the first round and then leave the rest up to you. So, okay, we're gonna define 4 functions here. So, f of x is going to be x plus 2. G of x is going to be 3x squared minus x. H of x is going to be the square root of 4 plus x. And k of x is going to be the quotient x over x minus 2. And so, all right, if you want to jump ahead, what you're going to do is compose every function with every other function in 2 ways. So you're going to do f composed with g of x, and g composed with f of x, and then f composed with h of x, and then h composed with f of x. And you're going to go through all of these. So f with g, f with h, f with k, g with h, g with k, h with k, in both directions. And for each one, you're going to compute all these. And for each one, you want to find the domain and put it into interval notation, which is either going to be open, 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 closed, closed, opened, or closed, closed. Okay? And so this constitutes activity 8. I'm going to go through and I'll do a few of them, at least a couple of the hard ones. So let's compute. So let's compute f composed with k of x. And I always like to write it like this. I go, this is f of, and the input here is k. Right? So it's f of k of x. And wherever you see an x and f of x, you replace it with k. So in this case, it's going to be k of x plus 2. All right. So what I've done is I've even put k here, and since f of x is x plus 2, f composed with k is k of x plus 2. And now we sub in k of x. We get x over x minus 2 plus 2. And you want to simplify this, so you need to find a common denominator. And the common denominator is, well, x minus 2. So I multiply the top and the bottom by x minus 2. And now that I have a common denominator, I can put everything over that common denominator, and then I have x plus 2 times x minus 2. And then lastly, clean it up. It is, x plus 2x minus 4 over x minus 2. And finally combine all the like terms, so it's going to be 3x minus 4 over x minus 2. And since I have all this white space on the left here, so what's the domain? So the domain of f of x is all real numbers, because it's just a polynomial. but the domain of k of x is all x's except for x equaling 2, because that makes the denominator 0. And so you look at the intersection of these two, so the domain of f composed with k is all x such that x is not equal to 2, sorry. So it's going to be all x such that x is not equal to 2. In an interval notation, it looks like this. You go from minus infinity to 2, open, because you can't put 2 in there, union with 2 to infinity. And so the final answer, this is the function, and this is the domain. All right, let's do one more here, just to give you a taste. Let's look at, where are they here? Let's look at G composed with H. Now, yeah, G composed with H. So number 2. G composed with H of x. Okay. That's G of H of x, which turns out to be, what's G? G is 3x squared minus 2. Okay, so it's 3 minus this, right? But the input is the function. So it's 3 of h of x squared minus h of x. Right? So, and what was h of x? H of x was square root of 4 plus x. All right. 3 times this. Oops, I don't want that color. I'm trying to keep the h red. Okay, 3 times the square root of 4 plus x squared minus the square root of 4 plus x. Now, I'm going to stop here for a second because the domain of 4 plus x, the domain is the square root of 4 plus x, so the domain of h of x is minus 4 to infinity. So at a minimum, that's the domain for G composed with h, because first you're going to input something into h, which has to obey this rule for its domain. And then that's going to go into the polynomial, which is good everywhere. So this will be our domain for G composed with h. Okay, so a little break there, break in the action. So when you take the square root of 4 plus x and square it, you just get what? 4 plus x. And then now we go minus square root of 4 plus x. Oops, is that what G was? Let me check. Yep, 3x squared minus x. Okay. And then let's clean this up. It's 12 plus 3x minus the square root of 4 plus x. And that's G composed with h. And the domain is going to be, so I do it in blue. So here's the function. And here's the domain. So don't forget, you have to do k composed with f and h composed with g, and then all the other combinations. So let's see here. Let's write them all out. So we're going to go, oops, I want this to be black. So you're going to find f composed with g G composed with F. F composed with H. Is that the next one? F, G, H, K, F, G, H, K. Yes, okay. F composed with H. H composed with F. F composed with K. K composed with F. G composed with H. H composed with G. G composed with K. K composed with G. And what's left? H composed with K. And K composed with H. And let's do a triple. Let's do a triple. We're gonna do G composed with F composed with K for the finale. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 problems. But 2 are done already above. And that's exactly how I like to see your work show up on these assignments. Have fun, and stop in for office hours tomorrow at, what time are office hours? 1:30 if you have any questions.